In this video, we'll show the relationship between GAUSS and the standard logistic function using array formula and exponent function. We begin with the GAUSS functions. Array formula, GAUSS of the x values from -2 to +2. And here you have the trend line and the trend line polynomial to the degree 8. And we generate the standard logistic function, which is equal to array formula. Let's start with the exponent. Exponent of -2 to +2 values of x. And factor in the negative sign. And then factor in 1 plus. 1 plus. And then factor in 1 over 1 plus. So 1 over the quantity 1 plus. So here you have the standard logistic function in red and the trend line and its trend line equation. We can convert this to the Gauss function. So we'll enter the same. We'll copy this, copy, and paste it here as text. So you have the green one. Now we factor in square root of 2. So this is times square root of 2. Then factor in plus 0.5. So we add 0.5. So that's 1 over plus 0.5. So 0.5 plus, and it should be negative. That means this green line will be along the origin. Now the green line is along the origin and we're closer to the value of the Gauss function in blue. We can now factor in 2 over square root of pi. So this will be times, and inside the parenthesis is 2 over square root of pi. 2 over square root of pi. Now they're on this. The green line are on the blue line. So they are now on the same trend line and their data sets match closely to each other. The trend line equation, they have the same regression coefficients. So like 0.399, 0.399 for x, for the x, and 0 for x squared. This one is already 0 times 10 to the minus 16. And for the x cube is 0.0643, 0.0656. That's very close. And x to the fourth, it's 0. This is very small. Times 10 to the minus 16, 4.52. This completes the use of array formula and exponent to show the relationship between the Gauss function and the standard logistic function.